Hello everyone. Very good morning to all of you and welcome to this session on a very important topic as evolving distributed grid system. Thank you very much for your participation to this session. My name is Luciano Martini. I'm with RSC. RSC is a national research center based here in Milano. We deal with smart grids and many things related to the power system, and we are giving and providing scientific support to the Ministry of Environment and Energy Security. And I recognize I've been quite unpolite with you because I just said the distinguished panelists, but I didn't introduce you. So now the time to introduce you each by one. So I would like to start with Martin Brown, Director, Grid Planning and Grid Operation at Fraunhofer IFER. Martin, thank you for being with us. Then we move on with Robert Denda, CEO of Grid Expertise. Thank you for being with us today. And then we have our colleague Ruben Llanes, CEO Digital Grid Schneider Electric. You will also bring in some view not only on Europe but also maybe on the American side. Thank you. Then we move on with our colleague Sahib Syed, Chief Product Officer of PTR, so a consulting firm. So we will have also different stakeholders debating on the same subject. Thank you. And then Nico Arcaus, Smart Grid Director at Iberdrola. Thank you for also being with us today. And Sylvia, you know Sylvia, she will be contributing, maybe also reply to some of the feedback on the report later on. So to start the discussion, we prepared a few questions. I would like you maybe to try to reply in a short manner, maybe 2 minutes maximum, to the first general question, that is, the distribution grid will need to constantly evolve to meet challenges thrown up by energy transition. But what are those key evolutions needed now and in the near future? And then, after this first, let's say, warm-up question, we can enter maybe, if you have a feedback on what we hear from Sylvia, you can maybe pick up one of the question A or B or C in order to see your first reaction on this feedback on the report. Since we have a different stakeholders represented, industry, utility, manufacturer, consulting firms, and so on, and research innovation, of course. We have also the possibility to see different views, also representing different countries, different aspects. So we expect you to reply to a question, but also maybe to also complement some of the reply from another panelist. So I would like to start with Martin, if you can give us your thought about this first question on the evolution, what is needed today.
Yeah, from my point of view, the need really goes in two directions. So one, I think, is very clear. The overall goal is to have a secure grid operation. And to reach that in the more complex energy system design that we have been sketched with decarbonized, decentralized, we need to use digitalization, a full automation of system operation in order to be able to master this complexity and guarantee a secure operation of the power system. And this is extremely challenging because we are talking about, especially in distribution, to make a full rollout of automation technology with a quite heterogeneous approach from different manufacturers, different grid operators of different criteria. And the challenge is now to do this once in a life, full rollout actually, in a manner that it's at the end really also secure. And I think this requires a lot of cooperation and testing and anticipation of what is needed in order to realize that. So this is one direction which is very clear. A second one, which I already see from the German perspective, very important, is that the speed for grid reinforcement is getting throttled or slowed down because we are getting to limits of people being able to plan it. So we need automation and planning. We have limits of people building it. So we need to find priorities and ways of coming to faster building processes, and in the end, how to integrate faster more renewable energy in the system. And I talk about energy because the connection normally goes with power, and we see that we have in many areas connection limits on a power base in the worst case constellation for computing centers, for renewable energy plants and so on, because we plan for the maximum capacity, and we need to come to solutions that allow to integrate a maximum of energy as efficient as possible. And so these are two perspectives I see at the moment that are very critical for the evolution and need to be addressed very urgently.
Thank you very much, Martin, for starting this discussion. Now we can see, Robert, that you have a privileged view of different markets around the globe. What do you see as really an evolution needed today from your direct experience?
Yeah, so what we really see in the different markets, actually the same topic arises. So what you were just saying, it's always about, let's say, doing the investments in an intelligent way, because the problem is just coming so fast, let's say, towards us and towards the different grid operators, that in the end you need to speed up. I think in the report there are many things described here, but if you think about it, just going back one step, at the end you mentioned this, Martin, one thing is about the peaks. So, and the peaks have two aspects, let's say production and demand peaks, that is clear. At the other side, even if you avoid certain peaks or mitigate certain peaks, let's say the other aspect is what to do when you have a peak. So even if the peak is a little bit slower, you still might have it. And you don't have it, it's not the discussion of some years ago that you have a peak in the overall system. Now we speak about peaks in individual segments of the grid, in medium voltage, in low voltage even, let's say. And so it's deep inside the distribution grid. And what we see really around the globe, that now there's this focus on how to manage those peaks. And this is, I agree with what Martin said, let's say digital technologies are the key to that. You need to be able to monitor and control in real time those networks, the medium and low voltage networks, in order to mitigate those peaks. And that many things in the report come as well. It's a lot about flexibilization at the end of the topology. It's flexibilization of the demand. So you have this integration of what happens on the demand side, integration of storage, integration of many other interesting and new technologies that are there. And what we see, it coming back to your question, at global level, that actually there are things happening. So now many utilities are going in this direction, the technologies are there, and what we will probably see over the next years, there will be a further acceleration, especially in that particular domain. Also taking into account all the supply restrictions on the hard side of the grid with the transformers and cables and so on. Let's say the long lead times and difficulties to reinforce the grid physically. This will drive even further the topic that you also mentioned of digitalization. And this is a global phenomenon.
Excellent. We couldn't start better than this. Thank you, Robert. And now we heard about flexibility, we heard about digital solution. Ruben, do you want to comment? These are the solutions we need today.
Sure. First of all, Sylvia, terrific report. I thought it was very well done. So a few things that I would add. If you look at kind of the sizing of capacity, oftentimes we look at the peaks. And so there's been some specific examples where we've engaged with DSOs or some utilities in North America where we've looked, and those peaks happen maybe 5 or 6 times a year. So if you're basically sizing the network in order to be able to address those, I think in some respects you're overbuilding. So I think looking and making sure that you have a holistic view is something that makes a lot of sense. As Schneider Electric, we're certainly not immune to some of the global supply chain challenges. So that's something that we've certainly lived through. One thing that I'm very happy to hear has come up in both of our prior panelists here is this notion of digitalization. So that's where I spend a lot of my time, is how do we use technology in order to be able to identify specific opportunities, to be able to look at the overall usage and demand of energy and think about different ways where we're able to address some of those needs. So as I think about some of the things I see in the rest of your question here is what needs to happen in the near future. To me, regulation is probably one of the biggest single things that needs to be part of the conversation. Oftentimes we have this capitalization mentality where we're looking at hard assets. And now if we look at software and being able to look more at digitalization, looking at how you take more of a TOTEX approach to me is one that I start to see come to the forefront. And I'll just add, when I speak with different executives, they're asking us for support in speaking with regulators. Is they're saying, hey, we're having this conversation real time. How can we get together and try to make the case to the regulators to try to continue to evolve that thinking? To me, that's something that needs to happen in the relatively near future here.
Thank you so much. Going forward with the same question to the other panelists, it becomes harder because the most important topic has been already picked up. So your work will be much harder, I know. But the same question, what do you think is part of the evolution or needed at this stage?
I think it's very important to ask the question why and why now. And for that, I think how the power grids were established historically, that's a very important question. When you look at how everything was very rigid before, we used to call it point to point, generation needs to match demand, and that's all you need to do in power grids. And then you have more complex systems coming up slowly, meshed systems. They have to speak to each other as well. And then you have, and previously, transmission grid used to be called the backbone, because that's where the magic happened, And now you have decentralized generation, so everything is now connected with the distribution grid. So now the question of bidirectionality comes. So hence, that rigidity now needs to change to flexibility, which everyone mentioned. So this question that why now is because these power grids were not designed to manage the things that are happening now, decentralized generation, bidirectionality. We used to have a lot of rotating machines before in our grids. Now a lot of what we have is what we call non-linear loads. You have a lot of power electronics in the grid, so that grids were not designed to handle that. So the issue of inertia comes into the equation. How do you tackle that? The issue of reactive power comes into the equation. So that's, I think all these questions are important. Why now? Because what is happening, power grids were meant to be able to cope with all these changes. You have multi-megawatt loads popping up in the form of big EV charging stations. We're already talking about megawatt chargers. You put 5 of them in one place, you have 5 megawatt load popping up out of nowhere, right? So power grids were not designed to cope with these things. So that's why this question of how do you solve this, all the answers before. You need to introduce more flexibility, bidirectionality, why digitalization? Because in order to achieve all of this, you have to have a digitalized grid. You have to have more eyes and ears throughout the grid, which previously was not existent, right? So I think this is very important to see that previously how everything was designed, it was not meant to tackle all these unique issues, which are going to increase in the future. So I'll echo what Sylvia said in her presentation, that yes, it's a growing need, but it has to be done. Otherwise, what's at risk? We saw the numbers, the EV chargers, the heat pumps, data centers, all these massive demand centers that are expected to come online, that is at risk. So I always look at the comparison. I think that's what makes me, it makes it tangible for me to understand, okay, that's why we need to change. That's why it needs to evolve over time.
Thank you so much. Let's move now to Nico, Iberdrola. You know that it's not only the massive amount of renewables, but also how they are distributed. I was checking a few days ago the data from GSE, the Italian Gestore Sistema Elettrico, that in end of last year, we reached 1,600,000 PV generation unit. Can you imagine monitoring real time all of these units? Is a mess. How you deal with what is needed from Iberdrola point of view?
Well, I am the last one to close the first round, so I have to choose either to be very imaginative or be very brief. So I'll try to do both. Right? So in our view, the energy transition, and answering that question, the energy transition is based on 2 pillars: more renewable energy and the electrification of the economy. So the first one, I think, for the last few years, the message has been taken home. So has been socialized, and we all understand. Even my mother understands that we need more green energy. But the electrification of the economy needs networks. Full stop. Electrification of the economy at the energy transition will not take place without upgrading, expanding, reinforcing, and yes, digitalizing the network. But we need all of that, and that was very well presented by Sylvia's slides. So I fully agree with what all has been said, but the focus is on investing in evolving, expanding, upgrading, and digitalizing the network in this particular order. Flexibility, digitalization are helpers, and they may help, as Sylvia presented, they may help to delay some needed investment.
Yeah.
But the investment in old transformers and wires is absolutely needed. Without that, energy transition will not take place. And this is the imaginative part, because we can talk about fancy technology, wonderful technical solutions, that they exist and they will help to delay investment. But hey, let's go back to transformers and wires, because they are absolutely needed. If we do not invest in conventional networks and make them smarter, but we need networks, and then we will make them smarter, then the energy transition will not take place.
Thank you so much, Nico. So you talk about investment. That means you have also to make a good planning of what the evolution of your system. This was discussed in your report that you presented. So Silvia, do you have a comment on this question?
I
but in
have a
general?
comment because
Please.
I'd like to complement with the regulatory part, whose
Yes.
importance has already been recognized. We are in Europe, and I want to stress that the European regulation already recognized this important role of distribution and the importance and the necessity of investments, also in the Repower EU of those investments. So the framework is there at European level, and this framework deals with everything that has been said, with digitalization, with permitting, with the availability of hosting capacity, with very practical provision, for instance, on the availability of hosting capacity. DSOs and TSOs are mandated to publish quarterly updated maps on where capacity is available to facilitate connection both from generation and from distribution. Even the supply chain difficulties are tackled by the European policies and regulation through a push to standardization, for instance. So what is needed now? National implementation, a promptly national implementation of all the indication provided at the European level. There is a huge dishomogeneity among countries. There are countries that are very well placed as far as regulation is concerned. In other countries, we still see caps to investments. We still see that the recognition of the remuneration for system operators is delayed in time. Maybe it should happen like after 2 years. It happens after 5, 6 years, 7 years. So national implementation is what we need now.
Thank you so very much, Silvia. Now, if you like, we would like to see some reaction from what you presented from the report. And it was a very interesting report, a very interesting presentation. Going back this way, Nico.
Oh, excellent.
So we change
The
a
first
little
one.
bit. What do you think about one of the ABC questions? Which one do you like the most?
Well, I can touch on all of them very briefly. Obviously, Iberdrola is part of Euro Electric,
Yes.
so we cannot disagree on the report. We fully agree. I think the message that, I couldn't see the figures from here, but the message that we need investment, and partially that some part of that investment may be delayed because of digitalization, is a very strong message.
Okay.
I also like what you said about investment caps, and the report complements other reports in the past that have been all issued on the same subject. I remember the International Energy Agency, they also issued a report in a similar direction months ago. I also remember you were talking about European Commission, a report called Networks, the Missing Link, which also sends a very powerful message that networks, if we truly say that networks is the backbone of the energy transition, we need to believe it, that we are the backbone. So maybe, as I said years ago, all fuss was about the green energy, and now all the activity is focused on networks. No? So that is a good message and a strong message, and we really need it. With the country-specific issues, I work in Spain, and I would say the situation in Spain may be kind of like the Chinese sauce, sweet and sour. The sweet part is that a few weeks ago, the government published an update of the national plan for climate change and energy, the PNIEC. And the good news is that networks have the protagonism that we think we need in that plan. Obviously, a lot of mention about renewables, but networks has the main character with an estimation of investment in the region of 53 billion euros until 2030. So that is the good news, that is the sweet part. The sour part, so that is one, the government says, hey, we need to invest 53 billion euros in networks until 2030 to make energy transition a reality. The sour part is that another part of the government says, hey, distribution operating companies, you cannot invest more than a certain amount every year, because that is the investment cap we have in the country. And it's related to the national gross product. It's like something like 0.13% of the national gross product, which works well when the network doesn't need to face the challenges, the enormous challenges of the energy transition. So that cap has worked well in the past, but now it has to be either removed or revisited, because we cannot achieve the challenges and the obligations that the national plan imposes on us without that cap being either removed or revisited.
Okay, thank you. I have a feeling that we need a report like this one to give us a sense of urgency, but also a way forward and what we need to do. What do you believe, Saqib, on the report?
So the moment I saw some of the slides, the analyst brain of mine is asking me a lot of questions. So one of the things that I think would be very interesting to see is, because not every part of the distribution grid is created equal. So you have different problems arising from different segments. For example, you have the high voltage, or what you call the where the handshake occurs between transmission and distribution grid. I think that is there are different problems occurring there, and then you have the medium voltage and the low voltage. I think would be very interesting to see that what part of this is going to go for. I'm pretty sure that that's how it's probably calculated bottom up. But would be very interesting to see, what's the amount of investment needed for medium voltage grid, because that's where I completely agree with Nico's point that the hardware, the basics, the legacy grid equipment needs to be there. The substations and the transformers and switchgear, that's the basics. So I think for medium voltage network, that's what is needed. And on the low voltage side, I think that's where more digitalization needs to happen. You need to have more, again, eyes and ears, sensors. So that would be very interesting. From a country standpoint, I agree with Martin's point earlier. I think regulatory framework maybe needs to improve. I was interviewing a few people in Stuttgart a couple of days ago in a different conference, and spoke to a lot of charge point operators, CPOs, operating in Germany. And one of the biggest problems for them was sourcing a transformer, getting the grid connection. It takes 5, 6, 8 months, after they put a charging station, to get the transformer, to get the connection. More than 800 DSOs in Germany, and close to 500 or 600 of them have different, grid codes and requirements. So as a CPO, they have to know everything, So they oftentimes outsource. They're given an option, you can do it yourself, but they, that was one of the biggest issue that was raised. So I think from a country standpoint, I completely agree with Martin's point that that's where maybe more harmonization needs to happen. The whole process needs to be made a bit more streamlined. Otherwise, again, what we saw in Silvia's presentation, what's at risk, it's just you're going to be then delaying your net zero targets essentially.
Thank you. Now, Ruben, the same question. How is your immediate reaction on what you saw from the report? Is it interesting to you? Make a point that you feel comfortable with?
Very interesting. Again, I'll come back to the point on the hardware. It's kind of more or less what I expected. What I would have expected to come more to the forefront in terms of quantification would be the digital aspects in terms of being able to squeeze more out of existing physical assets that are there is something that I want to better understand. Like, what does that look like? As I've had different conversations and have looked into it, it would seem that there are more efficiencies that can be gained by virtue of different digital solutions that you're able to put in place. The second comment in terms of the anticipatory investment, so your part C, I really like the fact that customers were brought into the conversation. In the end, the energy transition will not happen if you don't have ratepayers, whether they're C&I or whether they're residential ratepayers, that need to come along for this journey. So the point that I want to make here is on the major event management is making sure that you're able to fortify the grid such that you're able to make sure that the lights always stay on and that you're able to bring them along. So whether it's around kind of vegetation management or whether it's around other investments that you can make around making sure that you create the resiliency are all things that I think are important to kind of bring out.
Excellent. Thank you. Robert, you saw the report. I think it's interesting to you. Digitalization is there, AI, maybe other solution. Can you comment on this?
Yeah, absolutely. No, I think there's one opportunity. Let me be optimistic as well here. From what we've seen, out of the 67 or 55 billion that you've seen, let's say, of annual investments, if you look at the numbers, if I saw it correctly, about 4 billion goes to smart metering, 4 billion distribution automation, smart grid technology, digital technologies that you put in the field. There is a problem that we've seen. There is the lead time, hardware, and I agree, let's say you need to reinforce the grids. At the same time, there's a challenge to make it happen. And there's, let's say, the supply chain, there's so many issues there. But at the same time, the digital technologies are already there. So I think even if you look over time, you can start in the proportion, have a strong initial part already with digital technologies while you continue over time to reinforce the grid. And this anticipation that you can do because the technologies are there. Today we can, let's say, automate the grid with distribution automation technologies that discover a fault in the net, change the topology in less than 1 second, for example. You have, let's say, very advanced technologies available today that you can see here also at Enlit. I think there are many things that we see this year that are very specific and unique in that sense, and the technologies are there. So I think that's a great opportunity that within this distribution of the investment allocation, I think the more we can, let's say, reach to anticipate that part, because that's the part that then also, following up on what you just said, enables the digital integration to everything that is on the customer side, on all the participants in the ecosystem are connected through this digital world. So while you roll out the hardware, let's say. You mentioned AI, so I wanted to maybe make a quick comment on that as well. I think this is a great opportunity, and we have not looked at one of the aspects here in the report. I've seen it, let's say, that is the skills. Because right now, we spoke about digitalization, but in order to roll out at speed, at the same time, many utility companies face a challenge that the people in the field, that the people that have done their work for the last, 20 years in a certain way, now should do it in another way. They go to a secondary substation and suddenly they see a digital device there with red lights blinking, and they say, so what's going on here, right? And there, I think, is a fantastic space of where AI can actually be of great use to, let's say, mitigate the skill gap that is there. Because that is a feature that will be of help in the control room. The same thing, if you look at the control room of a grid operator, let's say if you have a co-pilot kind of support from AI, this will be very helpful to take better, faster decisions apart from the full automation and be able to manage normal situations, emergency situations. So there's so much space where in reality, and that's why I said I will bring the optimistic part here, where AI can really, let's say, help accelerate and make this second part, the difficult part of the digitalization with the existing technologies happen.
Thank you, Robert, for touching this important issue of a new generation of electrical engineer and capacity building. This is certainly an issue. I also like your approach of advancing faster using digitalization. This is something we repeated many times in different international contexts. Whatever we reach by 2030 will really very much affect our possibility to have a net zero by 2050. So we have to advance faster, and this is a good way to approaching this problem. Now, Martin, the same question. You saw the report, at least at glance, some slide about the report. What's your feeling about it?
Yeah, I think it gives a very good overview about the situation. And well, the core message I would say on the top level is that if we want to come from a fossil towards a sustainable renewable-based power system, then the grid is the core to realize that. So without the grid, it doesn't work. And I think this is an important message because I think we see, if I look on the country-specific well, because the study is more on an aggregated level, so bringing in also the country-specific views, then I just mentioned that in Germany we already see that there is a difference between defining transformation path, saying, well, we will have 200 gigawatts PV by 2030 and 100 gigawatts of wind, and we have 15 million electrical vehicles and 6 million heat pumps. And by this, we will have 80% renewable coverage of power demand. Well, one is defining this, the other is realizing this. And we already see, and I like this speed up idea, we see that it somehow stopped because the interest of customers to buy electrical vehicles is very low. So we are completely out of the gradient that we would need to go in this direction. The same with heat pumps. So if we include the customer's perspective, so just for myself, if I look at my household, we are firing at the moment with gas. If I install a heat pump, it will not be cheaper because the electricity price is more than 4 times the price of the gas. So even the efficiency gain that I get from the heat pump doesn't compensate for this cost difference. So the question is how to incentivize the customers to go on these pathways that are absolutely needed from a macroeconomic perspective, but coming from a macroeconomic perspective towards a microeconomic ecosystem, there is still a significant gap. And this is something I like to point at. And a second point is with regard to the transformation pathways. We have now had our first round in Germany where the distribution system operators had to calculate their target grids for the 2045 vision of having 100% of renewables. So that was the first round where many distribution grid operators had to calculate this with complete different approaches on that, of course. And after having it done with scenarios, so we were, for example, providing for one region the bottom-up scenarios for that. After having this calculated, the reality showed that the scenario pathway is completely different. We are on a different track. So the planning we have for the future against what is happening in reality, there is a difference. And that's having this anticipatory approach of grid investments is extremely important, but we also have a very high uncertainty. We tackled that once in a study we did for a larger region in Germany, where we did automatic grid planning on a probabilistic way, saying, well, it depends where the new components will be connected and so on. And we showed that there are robust decisions where to invest in order to make this anticipatory effect. Because if I know quite robust that to 90% this investment is solid, so it's a no regret one, then I can do it. But there are others that are highly uncertain. So we have to have methods and frameworks that deal with this uncertainty, and on the other hand, frame this all action with political actions that are needed, and that is what we see. The one is saying we go this direction, but really following on track in this direction requires significant political action, beside of all the efforts the stakeholders are doing to realize it. So it's an interesting pathway that we have to go, and looking forward doing it together actually.
Thank you, Martin. Thank you all panelists for addressing this first question at best and sharing your view on that. Let's move on. We have an additional question to you, and I think one is extremely important. So you see the increasing complexity and demands on the distribution grid. What are today's most significant challenges related to power system transformation that grid operators and utility are facing? Maybe you can combine this question with the following by sharing with us what you are doing in this respect. So how you contribute and support this evolution of the distribution grid. And maybe I would like to start with Robert, asking you, you mentioned digitalization and AI. Maybe you didn't mention edge technology. We know that they can play a role. Do you want to share your view on this and what you are doing actually as grid expertise?
Yeah, of course. Yeah, we at Grid Expertise, in fact, we are a technology service provider, so we have hardware, software, service solutions for utility companies, exactly in the domain of the digital domain that we mentioned here. So to monitor, control the grids, to transform the grids in exactly what we're discussing here. And in fact, there's a new trend, new technologies that enable to go beyond the current generation and boundaries that we have, and they are, let's say, related to edge intelligence, edge computing, so that you make maximum use of all the computing power that you can bring to the edge, also inside the grids, in order to enable use cases that before seemed impossible. So to really go into what I mentioned before, let's say, technologies that detect the fault, reconfigure the grid, recover from the faulty section, so flicker in less than 1 second, for example. We have technologies at Grid Expertise that do that. Let's say we will be speaking in the upcoming months, it's not years, it's months, let's say, about the topology flexibility, because we always speak about the demand side and production side flexibility, but it's also topology flexibility, so that if you have your grid, let's say, with the different alternative ways, you can dynamically adjust the topology according to what has actually happened, and that means you need to in real time capture the effects that you have in the grid, and based on that in real time act upon that, and that requires edge computing capabilities, but it's there today. Then we have, let's say, then another aspect, all this integration versus the customer storage as well, but also customer side integration, so the control of a power plant in function of what is, so a power plant, generation plant, renewable plant, controller integration with what is happening at the grids. On the market side, it's one aspect, but bringing this to the control plane aspect is another side. Also here, edge computing technologies are the key. And the nice thing that you today have with the new generation, let's say, before many companies rolled out over the last, let's say, almost 20 years, distribution automation technologies, smart grid, first generation smart grid technologies that kind of allow to remotely control the grid, do, let's say, first automation, let's say, maybe not that real time, but it's already there. Of course, it has some cybersecurity and other aspects. Those are the many legacy technologies in the field. There are many things now with these new technologies that are much higher standards in cybersecurity, have, let's say, much more price point, much better price point and overall cost of ownership. Let's say there's an opportunity to use what we have as technology of today in the grids. And this is the opportunity that I mentioned before. Those are things we can accelerate today. It's not something of tomorrow.
Thank you, Robert. So many challenges, but also many opportunities, and a very exciting time. We have really to work fast, but also see new technology helping us during this journey. Can you comment on this? Which are the most significant challenges? How technology can help? Maybe technology you can provide.
Yeah, sure. So I'll start, actually I want to go back to the AI topic. I think this is a really important one.
It's one of the
This is one that we've actually put into our ADMS because we think that there's a couple of factors there. One is you have people that are retiring, which I think is important. But one of the questions that I oftentimes get that I just think is important to make sure that we continue to say is that it's not meant to replace operators. It's actually meant to augment what operators do. And the reality is that there's so much that's coming at them that they have to be able to synthesize in a way that allows for them to make quick decisions in this very complex situation. So I love that comment. What I would add here is our DERMS. So the amount of distributed energy that's deployed continues to proliferate. So for example, in California, every new home has to have photovoltaic on the roof and storage in the garage. And then you see some similar activities within Europe where you start to see a lot of the distributed energy that also is occurring here. So the point that I'd like to make here is I think the technology that needs to come into play is where you bring together the VPPs, so kind of the flexibility that is behind the meter, along with what's happening contextualized within the grid. And when you're able to bring those things together in kind of a one DERMS approach, to me this is where you start to see the ability to start to unlock some of the capacity that you have in all of this distributed resources. So I think this is one of the challenges that still needs to be unlocked given the amount of kind of flexibility there is within European markets that I think can start to be unpackaged.
very good. Thank you. Sahib, what do you think about the challenges? Challenges and solution maybe you are working on?
So what Nico said, I think that's the baseline. We need to ensure that the legacy grid equipment is there. And after that, I think all these solutions come into the equation. I think we need technologies which allow you to extract more from what you already have. Because and that I agree that it's going to be a rather quick fix, but it will buy you more time. Things like grid enhancing technologies where you're able to get more capacity out of the grid, I think that can be that can be really helpful in these situations. And also, once again, not every grid structure is created equal. So priorities will be different. For example, there was an example of vegetation management. That's a big concern in the US. Reliability of the grid is a big concern there. So, so all the energies of the utilities are directed towards reliability and adding more resiliency to the grid. But not so much here in Europe. I think that's where digitalization, because I think reliability-wise, already Europe has a better benchmark here compared to the US. So digitalization, I think, is a more important topic compared to the US, where undergrounding of the overhead equipment is more of a priority as of now. So technologies which allow you to squeeze more of what you already have, essentially, and being able to make your grid more flexible through digital technologies. I think that's what is needed as of now. On top of what Nico said, ensuring that you have the cables, the switchgear, the transformers. I think if that's the bottleneck, everything else is thrown out of the window. So once you have that baseline covered, then these technologies which allow you to buy you more time, so that you can think of these long-term solutions as well in parallel. So what you already have, it basically gives you more time essentially. And then AI, I'm sure that this is where we are headed. But I think there is obviously there's a lot of room for improvement here as well. I think education is an important aspect. So I'll give you an example. I started my career in fertilizer sector. Actually, I was the lead electrical engineer of a fertilizer plant, and I was once tasked to install a digital solution. So there was an issue with humidity, and then because of that, there was equipment failure. So I was tasked to replace the existing equipment with more of a digital solution, so that you're constantly able to see what's the humidity level and whatnot. And I was super confused because a lot of solutions out there, but for me, reliability was the biggest issue. I did not want to install something that could harm the reliability or electricity reliability to the plant, right? So then I think of utilities managing large networks. I can understand reluctance, before they move to a completely new solution, because for them, reliability is the name of the game. right? So I understand that. So I think education is extremely important. Things like total cost of ownership, I think that's something that we've learned that is extremely important. Someone being able to understand that, okay, if I replace my existing system with a more flexible, more digital solution, in the long run, that's the benefit that I'm able to get. So I think educating that or actually giving a direct comparison can be helpful. You know, we did a few studies on replacing the equipment with more CO2, let's say, light equipment. For example, SF6 is a big topic, sulfur hexafluoride, GIS switchgear. So a lot of the resistance actually was because of lack of knowledge that, you know, what's the total cost of ownership of one installing a switchgear where the maintenance is not that much needed over time. So, you know, over the lifespan of 20, 30, 40 years of switchgear, what's the benefit do you get out of it?
Thank you so much. Let's ask now the utility what they think, a grid operator. So we know that you cannot play with the grid and not with the customer, so a solution needs to be validated before. But which are the challenges from your point of view? And of course, I think you can agree more by using your asset at best, using digitalized solution and so on, but the challenges.
No, the challenges, we haven't mentioned it, but we are a regulated business.
Yeah.
So we are regulated and we are a business. So as a business, we need to obtain and attract the necessary funding from banks and investment institutions. And in order to attract funding, we also need a stable regulatory framework that sets up the rules for the next 5 to 10 to 15 years. And that is not happening. We open up regulatory periods in different countries, but we don't know the return on the investment yet that is going to be offered to us in the next 2 years, for example. You cannot run a business like that. So we need predictability, we need stability, and we need the regulator to understand that they need to take ambitious decisions in terms of allowing those anticipatory investments and all that. And yes, we will apply the technology, and yes, we will apply flexibility, edge computing, all that. When Robert was talking about edge computing, I was thinking that as a grid operator, we have been using edge computing 40 years ago, but it didn't have that term, that fancy term. We had protection relays that, because they need to open a circuit when there is a short circuit in milliseconds, they had the intelligence to operate the network locally, because we didn't have time to send the signal to a control center and for the control center to operate the network remotely. So that was a clear business case that 40, 50 years ago was met by installing edge computing, but they were called protection relays, right? So we are talking about smart grids, smart meters, smart technology. Smart grids, when we refer to smart grids, we refer to them as the distribution automation, smart meters, medium voltage, low voltage. But we had smart grids 40 years ago with SCADA and remote terminal units at high voltage level, but we didn't call them fancy names smart grids at the time, but they were smart, right? So we need, I'm not answering your question about challenges, but when talking about the smart grids, the challenge is to educate the regulatory authorities to be smart enough to take ambitious decisions in terms of defining that regulatory and predictable framework that we need as a business to invest.
Innovation and regulatory framework is also important. That's
Yes.
clear. In Italy, we are quite lucky because ARERA is a very advanced regulatory authority. We have also the possibility to have exemption and to have also kind of sandboxes, experimental sandboxes. This help to try solution and to see if they are validated in field and applicable in the real time.
Absolutely.
It's important.
Absolutely.
Sylvia, not just with your electric hat, but apart from the report, which are the challenges you see from your experience and your knowledge on the system evolution?
My fellow panelists all mentioned innovation as a challenge, but also as a solution. And you said that innovation can be applied to regulation, and I cannot agree more. Regulators can and must be innovative. And you also mentioned Italy. this is a very good example, actually. So for once, a good news. The Italian regulatory framework is quite supportive for innovation. So Italian DSOs, for instance, have been pioneering the smart grids. We are now completing the second rollout of smart grids that will allow, for instance, 15 minutes load curve, and so will allow the participation of customer to flexibility services in perspective. But also we are pioneering, for instance, in Italy, the TOTEX approach for the remuneration, which puts together CAPEX and OPEX. And this is a very important news also that is starting to be applied this year in 2024, and progressively we go on to the integral application. And also incentives to network developments is another regulatory innovation that we are seeing in Italy. Network developments including climate resilience, digitalization. Of course, regulators must carefully take into account the interest of the energy system security reliability, but also the interest of consumers. And this is why the incentive regulation in Italy for network development is based on a solid CBA approach. So it must be demonstrated that benefits will overcome costs. So we have plenty of examples of innovative regulation. I think Italy can be a good example.
Excellent. I cannot agree more. Thank you so much. So before coming to the last question, because we are the one standing between these people having lunch, so maybe you have a final comment before we come to the final conclusion. Any additional comment, Martin?
Yeah, I just wanted to finish the round because
You missed the last one. You recognize you missed it.
Yeah, so I think we missed as a stakeholder the research within, and I think with regard to the challenge we have actually, with the energy system transformation, we have the biggest project of mankind actually ongoing to change a fossil-based power system, energy system, towards a renewable-based. And this is such a big challenge that innovations are crucial. So we have so many problems to solve. And so it's a privilege for us as Fraunhofer as a stakeholder on this side to bring in innovative approaches and to realize them, so bringing innovation into reality with partners. And so I think this is the core issue to work on innovation partnerships, where we have cutting edge new methodologies and solutions together with a practical understanding of how to get them into operation. And this is something where we support in many ways, such as supporting developing future scenarios and having robust planning pathways for the infrastructure with automatic solutions on this side. And so important in that sense is also to build more and more on open source solutions. So I think this has come as a clear point that proprietary closed solutions are getting less attractive because we need to be agile. We need to be able to complement different solutions together. And so on the one hand, we have open source solutions. So as just as an example, we developed Panda Power in our premises, which is very well received, and where many grid operators integrate that in order to have open source modules in that. And it implements also with modular operation frameworks. And this is something we have been working on for more than 10 years in order to build innovative modules of grid operation on top of existing control center solutions. And I think this is important, to be agile and see how we can get new solutions inside without tapping the full large complex infrastructure there. And this is going towards self-healing grids and things like that, where, and I think this is making the round that we are already having, we need to solve it by automation. Automation is core to being able to operate this more and more complex getting system. And so we need to get data. So data ecosystems are core to be able to have consistent, high-quality data sets that can be addressed and be used in order to train AI solutions actually in a really solid manner that allows that in the critical infrastructure of a power system, these AI solutions can operate secure. I think we are there at the very beginning of a big change with regard to that, and we need to learn how really to make artificial intelligence, automation solutions secure in the future power system. And this is also something that you find in the UI AI Act that defines for critical infrastructure specific testing requirements. And so for me, it's just a paradise actually of a lot of questions and challenges that need to be solved. And it's so exciting to get things forward, but we have really big nuts to crack. So it's...
Thank you, Martin.
Can I just make a quick comment on customers, just 30 seconds? Because Martin talked about residential customers. He gave examples of a heat pump, electric vehicle, and residential customers are responsible for 99.99% of the voting at the general election, right? But in terms of electricity consumption and power demand, it is just about 20-25%. So do not forget about industrial customers, that they demand 70% of demand and power, that they also need to be electrified because we have a challenge there and we need to serve their purposes. Otherwise, they will not be electrified.
Good point, good point. Being part of a research and innovation world, I cannot neglect the role of innovation. And I would like to remember maybe a number that we received from IEA, that 2/3 of a technology we need to get to the net zero are already available. So we need to invest, we need to implement, we need to roll out. But 1/3 of those technologies are still to come, are still in our labs, still need to be moving at higher TRL, higher level of maturity. So we have some work to do for them to make it practical, available. Thank you. So 3 minutes to go. So I think will be nice if you can just make in one sentence, 30 seconds, a key message you want the audience to take home after this panel. And thank you for all your contribution. Sylvia, let's start with you.
Okay, I see that the distribution, the new role of distributors is being recognized at all levels. So now it's the time for policymakers to have a vision, a holistic vision with a forward-looking approach, and to support investments.
Perfect. Nico.
Well, playing with words, we started with grids for speed.
Oh, yeah,
I will end with speed for grids, please. Because without grids, energy transition will not take place. So speed for grids, please.
Excellent. Thank you. Very positive message as well. Saki?
Power grids need to evolve. It needs to happen quickly, but we need to do it intelligently. We need to ensure that whatever the plan is, the supply chains are secured. We are using whatever we can from the grid already, so that those intelligent solutions are put in front of the priority list. And then obviously that gives you more time in the long run to solve your problems.
Thank you. Ruben.
Sure. What got us here won't get us there, is what I would say. What I mean by that is choose a technology partner that you trust. I think that you fundamentally need to think about the way that you're coming up and solutioning so that you're able to do this in a much more rapid pace than has been historically done. So accelerate would be the one word that I would ask to end with.
A very important keyword, I agree. Robert.
Yeah, I think that goes quite along with what you just said. Partnership is my keyword here, because I think we have all those ingredients, even though there's space for innovations that we still need to develop on. All of this happens through partnerships, applying technologies, digitalization, upskilling can only happen, let's say, working together in the segment. And I think we have many pieces of that challenge here, let's say, in this room, in this event, let's say, working together, we can make this happen.
Very positive message, cooperation, and toward to accelerate. Martin, maybe you have a final word.
Oh, that's great. So from my point of view, there are two key ingredients for the future power system. One is a cognition, so AI-based intelligence for realizing full automation. And the second one is resilience. So we design a critical infrastructure, we rely completely on it, and it needs to be a really resilient infrastructure. And concluding on that, I think we need to build innovation partnerships together in order to solve that and come to this vision.
Thank you very much. I think it was an interesting discussion. More time, more discussion on other topics to be brought in. But I would like to thank all the panelists. Please join me with a round of applause to all the panelists. And thank you to the audience for being with us till the last moment. Thank you so much. Enjoy the rest of Enlit.